In question number 6, we have a push broom of mass M. It's being pushed across a rough horizontal floor. So this should kind of stick out with you for you. There's friction there. And we have a force of magnitude T directed at an angle theta as shown in the sketch. The coefficient of friction between the broom and the floor is mu. They want to know the frictional force on the broom handle. Well, one of the formulas on your equation sheet for frictional force is mu. In this case, technically, it'd be the coefficient of kinetic friction, but we haven't discriminated between the static and kinetic coefficients in this problem. So it's just mu times the normal force. Well, none of the answers appear to allow us to use the normal force. We're going to have to substitute something in for the normal force. All of them start with mu, so we can kind of see that in each one of the cases. We just need to figure out what's going to go in for the normal force. In order to do that, we're going to have to write a dynamics equation in the y direction. And we know that the sum of the forces in the y direction is equal to 0. Our evidence for that is that the broom of mass m is not accelerated up or down. It's moving side to side only. It's actually at rest in the vertical direction. And so we're going to tally up our forces in the y direction. The first one is the y component of the tension force, or whatever we want to call that down and to the right force. It's negative. So I have negative Ty, and the normal force is positive. It's pushing up, so that's in the problem. And the weight force is in the downward direction, so I have to remember to subtract the weight. And those are the three forces acting in the vertical direction, and I'm going to set them all equal to 0. And I'm going to solve this for the normal force. And when I do that, by adding both Ty and mg to the right-hand side, my y component becomes t times the sine of theta after I resolve my vector t into its y component plus mg. And it's going to be that description for the normal force that gets substituted into my frictional force equation to give me that final answer of the frictional force is equal to mu. Now I'm substituting t times the sine of theta plus mg. And when I do that, I can see that choice A in this case is the best answer.